Welcome back to my YouTube channel. In the course of this video lesson, I'll be solving different practice questions that cut across different topics in chemistry. Now let's get into the practice questions. The first question. The question says, if 30 centimeter cube, this is 30 cm cube of oxygen, diffuse through a porous pot in 7 seconds, how long will it take 60 centimeter cube of chlorine to diffuse through the same pot if the vapor densities of oxygen and chlorine are 16 and 36 respectively? Now, how do we solve this question? It is extremely very easy. Now let's solve together. So the first thing we have to do here is to bring out the parameters involved solving this particular practice question. And the first thing I saw, listen carefully, I saw if 30 centimeter cube of oxygen. Oxygen is a gas. Oxygen exists as a gas. So it's going to be like O2. Are you following me? It's very, very important. But now let us progress. First of all, I saw a volume. So basically, I will call that volume V1. That was the first volume I saw. Specifically, it was the volume of which gas? Oxygen gas. And it was what? 30 centimeter cube. This 30 cm cube of oxygen gas diffused through a porous pot in 7 seconds. That means that was the first time I saw in the question. So it's going to be T1, and it is the time for it. It took the oxygen gas to actually diffuse through the porous pot. Okay, porous means a pot with hole. Do you understand? So definitely the time is what? 7 seconds. So moving further, let us progress. The question now says, how long? That means they are asking us to get time. How long? Time. And the time they are asking me, since we've gotten our T1, definitely it is T2 we are asked to get. How long will it take? That means, will it take what? 60 centimeter cube of chlorine. That means that was the second volume I saw. And that is the volume of what? Oxygen. Sorry, that's the volume of what? Chlorine gas. Because I said that, how long will it take 60 centimeter cube of chlorine? Do you understand? So that will be the V2. And it is for which gas? Chlorine gas. Remember, chlorine exists as Cl2. Hope you get this exists as Cl2. Please note this is very, very important. So how long will it take 60 cm cube of chlorine gas? So here is what? 6 centimeter cube of what? Chlorine gas. Do you understand? So definitely we are looking for the time it will take chlorine specifically. So it's time of what? Chlorine. So this is what we are asked to get in this particular practice question. It is extremely very easy. They gave us the vapor densities of the gases, chlorine and oxygen. Okay. So first of all, vapor density VD of which of the first gas, which was oxygen gas, was given to be what? 16, because they said 16 and 36 respectively. I believe you know what that means. 16 will be for the first gas, 36 will be for the second gas, chlorine. So vapor density of which other gas, which is chlorine gas, is what? 36. It's actually very easy. So you can see that we've brought out all the parameters involved solving this particular practice question, and it is very, very easy. So what do we do next? It is extremely easy. We have to go back to where this particular question is coming from, because from the look of things, this question is from a gas law, which is called the Graham's law of diffusion. Now, if you've not watched my full video lesson under the gas laws, it is important for you to go watch that video where I explain the rudiments to each of the gas laws. And in that particular video lesson, I solved practice questions. So it's important for you to go watch that video. The link to access that video will be in the description of this particular video lesson. Make sure you watch this video till the end, because I'll be solving different practice questions in chemistry. So let us progress. From the look of things, since I saw diffuse, I already know that the topic or the concept of the gas law to which this question is from is simply called the Graham's law of diffusion. It's simply called the Graham's law of diffusion. or we can as well call it Graham's law of effusion of a gas. So it's going to be Graham's law of diffusion or effusion of a gas. So on this, what do we do next? We have to remember what this law states. And this law states that the rate of diffusion or effusion of a gas is inversely proportional. Inversely proportional is going to be 1 over inversely proportional to the square root of its density. Take note, the square root of its density, or we can as well say that the rate of diffusion or effusion of a gas is inversely proportional to the square root of its molecular mass. Are you following me? So if you observe, we are relating the concept of Graham's was trying to relate rate and density, or we can as well call it vapor density, and also rate and molecular mass. Do you understand? In that particular video, I solved different practice questions and also derived different formulas. So it's important for you to go watch that lesson. Now, you know, when we bring out this formula mathematically, it's going to be something like R1 over R2 is equal to root of D2 over D1. I explained this because from the look of things, it means that rate and density, they are inversely proportional. As rate increases, density will decrease. Do you understand? Same applies to this. If I were to bring out the formula for this relationship, is going to be almost same, which is R1 over R2 is equal to root of M2 over what? M1. It's still the same representation, just what change is density and molecular mass. I believe you are following me. So on this, it's very important for you to understand the concept, and we derived other formulas under this particular aspect. So the question we ask, what do we do next? It's very easy. When I see questions under this aspect, I already saw vapor densities given. So what do you think we use to solve this question? It is extremely very easy. I'm going to work with the part of the formula that has density. So let us leave the molecular mass alone, and let me just wipe this out. I can actually still use this to solve, but this will take longer time. Okay, so it's important for us to work with the formula. I believe you've written down this formula in your notes because it's going to help us solve questions under this aspect. I'm about wiping it again, and then let us derive the formula to solve this question. So what do we do next? It's simple. They've given us the densities already, of vapor densities of the gases, and now there's something you have to watch out for. You have to know that rate has its own formula, and it is volume of a particular gas divided by time taken for that gas to effuse or diffuse. So what this is telling us that, is telling us that volume and time, they have relationship. So what type of relationship is between volume and time? Is it direct or inverse? It is simply inverse relationship, which means that volume is up and time is at the denominator. So what this will tell you that it is inverse proportionality that connects volume and time. It's simple. As volume increases, time reduces. If time was here, like volume times time, it's going to be direct. Simple mathematics. Do you understand? So put that in your mind that volume and time, they are what? Inversely proportional. Just watch. Just watch. Simple. So what do we do next? Remember the formula which I wrote earlier, which is R1 over R2 is equal to root of D2 divided by D1. And we already know that this D means vapor density, or we can actually just call it density. And now this is rate. This is what? Rate. Now what do we do next? Remember I said that rate relates both two parameters, which are volume and also which is what? Time. And I told you that volume and time, they are inversely proportional. As volume is increasing, time will definitely what? Decrease. So this will tell you that I can actually restructure this, remove rates, R1 over R2. Remember we are dealing with two different gases, which is chlorine and oxygen gas. I can actually restructure this part of the formula to connect volume and time, which I've done in that particular video lesson. And here is it. Listen. See, this is volume 1. I'll simply write V1 here. Listen carefully. And we already know that volume and time, they are inversely proportional. So as volume is increasing, time will decrease. So definitely, do you think I should write T1 or T2? T2, V1 T2 divided by, okay, this is just simple concept. You have to understand this is very easy. So then here is V1. So what will become here? V2. Do you understand? And what will become time? T1. You can see that we've removed R1, R2 because I told you that rate relates volume and time. So which we've done here. So V1 T2 over V2 T1 is equal to root of D2 over D1. It's actually very easy. Okay, this is the formula we actually need to solve this particular practice question. Yes, it is simple because you can see how I actually brought it into the formula, removing R1, R2 and incorporating V, volume and time here, because this will not change. Is a very important parameter needed to solve this particular question. So let's input our parameters. What's V1? V1 is 30. So here it becomes 30 centimeter cube times what's the T2? We have to be careful. T2 is what we are asked to get. So here become unknown over what's our V2? V2 is 60 centimeter cube. Okay, 60 centimeter cube times what is T1? T1 is 7 seconds. Okay, 7 seconds is equal to root of what's the D2? What's the second density? Now, how do we get this particular aspect? It's simple. You can see that oxygen was mentioned first. So oxygen basically takes the first density, which is 16. So definitely this is D1 because that was the guy they mentioned first, 16. So chlorine will be D2. Do you understand? Chlorine will be what? D2. So here is D2. So what we do is going to be root of D2, which is 36 divided by D1, which is what? 16. I believe you are following. It's extremely very easy. So what do we do next? Let's do the root of this first. So root of 36 divided by 16, that's 1.5. So I'm already having 1.5 here. So it's going to be 30, okay, centimeter cube times T2 is over 60 centimeter cube times 7 seconds is equal to 1.5 over 1, okay? Cross multiply. So what do we do next? Make T2 subject of formula. Making T2 subject formula, what are we having? T2 will now be equal to, when you're making this subject formula, everything here with times. 60 times 7 times 1.5 dividing 30 times 1. Simple. So it's going to be 60 centimeter times 7 seconds. This is seconds. SE is seconds times what? 1.5 divided by divided by 30 centimeter cube times 1. So T2 will now be equal to, let's press our calculator to get the final answer. So it's going to be 60 times 7 60 times 7 times 1.5. Okay, answer divided by 30, that is 21. So the time taken for the other gas to diffuse through the same porous spot is 21 seconds. And what is that gas? Chlorine gas. It is extremely very easy. I believe you know how this question was solved. Okay, now make sure you watch that my particular video lesson on gas laws to understand the rudiments of more formulas under the Graham's law of diffusion. Now, if you are preparing to write the JAMB exam, post UTME exam, or you are in your first year in a university and you are finding chemistry calculations difficult, here is the chemistry masterpiece written by me that has made that particular aspect very easy. Now, if you wish to get your own copy, do well to direct message me via my WhatsApp number. It will be on the screen. Okay guys, moving further, let's get into the next practice question, which says a gas occupies 30 dm cube at STP. This particular value is very important, and this is also extremely important in solving this particular practice question. So I read again, a gas occupies 30 dm cube at STP. What volume would it occupy at 91 degrees Celsius and 380 mmHg? Now, looking at this question, it is still on gas laws. So make sure you go watch that video to understand the rudiments to which questions can be solved on gas laws. But I'm still going to make this particular practice question very easy for you to understand, because me looking at this, I already know where this question is driving towards. Listen carefully. Let us solve together. A gas occupies 30 dm cube. This is volume. Dm cube is volume. Cm cube is volume. Do you understand? Liters is volume. Milliliters is volume. Meter cube is also volume. So this was the first volume I saw. So definitely I'm going to call it V1. Listen carefully. So V1 was 30 dm cube. Then I said that this gas occupies 30 dm cube at STP. What does STP means? Very, very easy. STP means standard temperature and pressure. Standard what? Temperature and pressure. So the question we ask ourselves, what is this standard temperature and pressure? There are values. They are what? Values. What is this standard temperature and pressure? They are values. So what is the standard value for temperature? It is simply this, 273 Kelvin. What is the standard value for pressure. It is simply this 760 mmHg. But the reason I'm doing this, I'm going to explain to you. The reason I wrote this, I'm going to explain to you. Listen carefully. So you can see that we've gotten the standard values for that particular gas. So definitely, what becomes the T1? What becomes the T1, which is the first temperature? So in the question, 273 Kelvin. What becomes the P1? What becomes it? 760 mmHg. Wow. So this particular question relates volume, temperature, and pressure. So which gas law should we talk about? We should talk about the general Gauss law, which formula is P1V1 over T1 is equal to P2V2 over T2, because it has all the parameters, both pressure, volume, and temperature. Remember, all of these were the guys that basically describes gas behavior, which I explained in that particular video lesson on gas laws. So what do we do next? We have to now ask what volume, because I've interpreted this first part of the question. I've interpreted this first part. So the other part says what volume. That means they're asking to get V2, okay, in dm cube as well, because this was expressed in dm cube. Would it occupy at 91 degrees Celsius? So T2 now, second temperature is 91 degrees Celsius. If you observe, it was expressed in degrees Celsius. Don't leave it that way. Make sure you convert it to Kelvin. And how do you convert degrees Celsius to Kelvin? Remember the formula I gave in that particular video, which is Kelvin is equal to degrees Celsius plus 273. So what do we have for our Kelvin, which is 91 degrees Celsius as stated in the question, plus 273. So 91 plus what? 273, that's 364. So Kelvin here is going to be 364, okay, Kelvin. So here, this 91 will be converted to Kelvin, which we've done. So we're having 364 Kelvin, K. And what was the pressure too? The second pressure we had, it was 380 mmHg. Now, here is the reason why I wrote this particular standard pressure to water 760 mmHg. Are you not seeing that they are both in the same unit? You have to make sure that they are in the same unit. If this pressure given to me was in ATM, for instance, here it's going to be written as 1 ATM. 1 ATM is still standard pressure. I believe you are following me. If it was written in a particular unit, I know I'm going to write the particular standard unit for that particular unit. Are you following my point? So that's how it works. It's very easy, because the other pressure I saw was expressed in mmHg. That's why I wrote it to be mmHg. If it was expressed in ATM, I'm going to write 1 ATM. Are you following me? So then what do we look for? We are looking for V2. We are looking for what? V2. So let us make V2 subject formula. Making V2 subject formula, what are we having? Okay, P1 V1 times T2. You know, everything with times. Everything here with times. Dividing P2, okay, times what? T1. I believe you are following. It is extremely very easy. So the next thing we do is impute our parameters. So moving further, what happens next is going to have V2 will now be equal to, what's our P1? What was the first pressure? 760 mmHg times what's the V1? 30 dm cube, okay, times what's the T2? Is it 91 or 364? 364, note that. 364 dividing P2, 380 times T1, 273. Do you understand? 273. So let's hit our calculator to get our second volume in dm cube, because this was expressed in dm cube. If there was a cm cube, it's going to have, your answer was here. We have to get, it's still going to be in dm cube. So 7 in cm cube rather. So 760 times 30 times 364 dividing 380 times 273. That's 80. Wow. So I'm having the second volume V2 to be 80 dm cube. So here is the answer. So the question is extremely very easy. Do you understand? So that's how questions under this aspect are being tackled. So let's get into the question number 3, which says the idea of planetary electron was that of, meaning that they are asking us who brought about the concept of planetary electron. Now, okay guys, let us move over to the next practice questions, and let's get into question number 4. And it says 0.07 grams of anhydride of carbon. Please let us understand what this means. It's very important. They said 0.07 grams of what? Anhydride of what? Carbon. So what does this mean? You know, whenever you hear hydride, listen carefully. Whenever you hear the word hydride, it means that the major element here is hydrogen. Are you following me? But then I said that hydride of carbon, meaning that hydrogen is combined with carbon. Please get that in your mind. It's very important. Then I said that 0.07 grams of anhydride of carbon, it means that it is simply hydrogen and carbon together, occupies what? 56 centimeter cube at STP. Okay, they told us that this particular hydride of carbon occupies what? 56 cm cube at what? STP. Wow. At what? STP? STP means standard temperature and pressure. You can see we are still seeing the word STP again. So what do? Simple. When vaporized. Let's stop there because I'm seeing another and contains will get there. When what? Vaporized. Wow. Let's just progress. And then it contains 14.29% biomass of hydrogen. Meaning that they gave us the percentage of hydrogen in the compound. Because we have two elements here, hydrogen and carbon. Are you following me now? You know, percentage is over what? 100. So definitely for hydrogen, they gave us to be what now? 14.29%. What was the percentage of carbon? Did they give it to us? No, they did not. But we can actually get it. Just follow me. I'm going to work more on this. Just listen carefully. Okay, before we do that, let's just get the percentage of carbon. Remember, percentage is over 100, right? Percentage is about 100. So definitely when we add carbon and hydrogen together, it's going to give us, it's supposed to give us 100%. Thank God the question, they gave us the percentage of what? Hydrogen. So what do? Carbon is unknown. Percentage of carbon is unknown. Okay. Percentage of carbon is unknown. Hope you're following me. Simple. Percentage of carbon is unknown plus percentage of hydrogen given already to be 14.29% is equal to 100%. So percentage of carbon is going to be equal to 100% minus, because when this one crosses, it becomes minus 14.29. Hope you are following me. Simple. Minus 14.29%. So what are we having? 100 minus 14.29%. That's 85 points. Listen, that's what? 85.71%. Wow. 85.71%. So we've successfully gotten the percentage of what? Carbon, 85.71%. Hope you are following me. I'm trying to read the question carefully so you'll be able to understand. Because I'm seeing different topics in this particular practice question. And I already have video lessons on them. I'm going to tell you the topics that are here so you understand them. You know, you have to understand the topics first before you can actually come here to solve this question. But I'm still going to do a quick recap, which I'm doing now, to be able to solve questions under this aspect because they are very, very important. Okay, so next step, they gave us volume at STP and they gave us the compound. This was the volume of the gas at STP. Okay, sorry, volume of the hydride of carbon at STP. Listen, this was the volume of the hydride of carbon at STP. What's the mass? 0.07 grams of this same hydride of carbon. Are you following me? So what do we do next? Because now the question, they are asking us to get molecular formula. Wow, they're asking us to get what? Molecular formula of the hydrocarbon. Because the question is asking us to get molecular formula. What's molecular formula? Molecular formula of a compound is the actual way that compound exists. While there's another called empirical formula. Empirical formula is the simplest way that compound can exist. Let's check our option if we can actually, be smart to solve this question without even solving. Listen, I said that molecular is the actual it exists. Empirical is the simplest it can occur. So, A, is it not CH4? Can I further break this CH4? Because if there were, I can't break this CH4. I cannot. Because here is 1, there is an invisible, and here there is 4. They cannot cancel each other. So definitely, I will call option A, CH4, which is called methane, to be an empirical formula. And is it what they asked us? They asked us the molecular formula. So this is already out. This can't be the answer because this is empirical. It's not molecular because it is the simplest way this compound can exist. I cannot break it further. Now B is C2H2. C2H2 I can actually break it. So definitely it is not an empirical formula. It is a molecular formula, but I don't know specifically which type of molecular formula is it. Okay, based on the question given to us. This is also a molecular formula because we can actually break it down to get a simpler formula. which to get and to get an empirical formula. Do you understand? So this is a molecular formula. This is a molecular formula because we can actually break it down. For you to know that something is molecular, you can actually break it down. So my point here is this: can you actually use this concept to solve this question? No, because we have 3 compounds that are molecular here, whereby one is empirical. So you cannot just want to outsmart the examiner and just choose any of them. You won't get the answer correctly. So you have to know how it's solved, which I'm about explaining. Now there is a relationship between I'm going to use EF now, empirical formula and molecular formula. There is a relationship between both of them. There is a formula that relates both of them. And what's the formula? It is simply empirical formula, open bracket, close bracket, N is equal to molecular formula. Listen carefully, it's very important. Okay? Empirical formula, open bracket, close bracket, N down is equal to what? Molecular formula. So what do we do next to solve this question? Very easy. First of all, there is something I want to do. There is something I want to do, because this formula can be further written as this: empirical mass, open bracket, close bracket, N is equal to what? Molecular mass. Are you following me? Just hold on. You can say I said that this can also be further written as this. We'll use this formula to solve a particular question. We'll use it. Listen, we are going to what? Use it. So first of all, the question you ask me, what do we do? Now listen, I have gotten percentages of 2 elements, which is carbon and hydrogen. So with this, I can actually get what we call empirical formula, because carbon percentage is 85.71, hydrogen percentage is 14.29. I can actually get what we call empirical formula. Remember the steps to get empirical formula? I did have video lesson that explained the rudiment on getting empirical formula. First of all, you divide by the atomic masses of the elements involved. What are the elements involved? Carbon and hydrogen. What's the atomic mass of carbon? 12. What's the atomic mass of hydrogen? 1. Something you should know. Atomic mass is basis. So we divide first the percentages given by the atomic mass of the element. So we divide by 12, divide by 1. So let's do that. So 85.71 divided by 12, that is 7.1425, and this divided by this is still 14.29. So do you understand? You can say I got the stuff, the values. So the next step is to now divide by the smallest. After dividing by atomic mass, you divide by what? Smallest. So between both of them, which one is smaller? This is smaller. So it's going to be 7.1425. So divide, both of them dividing each other. What are we having? 1. Both of them dividing each other. Let's do that. Okay? Let's do that. 14.29 divided by this. 14.29 divided by 7.121425, that is 2. Wow. So we're having 2. So we've gotten the empirical formula. So with this information, what is the empirical formula? The empirical formula is going to be, okay, let's just wipe this question first. Okay, the empirical formula is C1, because here is carbon, 1 of carbon, and H2. So definitely empirical formula is simply CH2. Is that the molecular formula they asked? No, they asked what now they asked for molecular, but what we've got is what? Empirical. Doing this is you getting empirical. Doing this is not getting molecular formula. Are you following me? How do you get molecular formula with this formula written? Do you get the point? It's very, very easy. So you can see that we've gotten empirical formula. Okay guys, what do we do next? Listen carefully. This empirical formula, I'm going to impute it here with this formula. Listen, this one is just something I will work on later. Let's work on this up one now. It's going to be empirical formula, which is what we've gotten to be what? CH2, open bracket, close bracket, N is equal to what? Molecular formula. This is what we are asked to get, molecular formula. This is what we are asked to get. Can we actually solve it like this? No, it's not yet complete. Remember I said that we can actually change this formula to this. Empirical mass, N is equal to what? Molecular mass. It's simple. It's simple like ABCD. Just watch. What do we do next? First of all, were we given this MN means molecular mass? Were we given molecular mass in this particular practice question? No, we were not. So how do we get molecular mass? We have to go back to a topic in chemistry called mole concept, which is a basic topic to understand the topic stoichiometry. So then I have to go back to mole concept. I have to go back to what? Mole concept. Remember, in mole concept, we have to understand this symbol, which means number of moles. You know, number of moles is given by 5 formulas, which I already have in my video on stoichiometry, so it's important to watch it. So this is number of moles. There is a formula for number of moles that has molecular mass in it, because for we to get molecular formula, we need molecular mass. For we to get molecular formula, we need what? Molecular mass. Then there is a formula that has molecular mass in it for number of moles, and that is this formula. The formula is simply number of moles is equal to mass divided by molar mass. Here is the formula. Are you following me? Here is the formula. The question is very easy, it's just about practice. Okay, and there is another formula again for number of moles that we have a formula. That formula is at STP, because I saw STP in this question, and there is a formula for number of moles that has STP in it, and that formula is number of moles is equal to volume at STP divided by 22.4 dm cube. Listen, divided by what? 22.4 dm cube. But because the volume given to us in this question was expressed in cm cube, it's going to be 22,400 cm cube. It is simple. Here can be in dm cube or cm cube. Why did I change to 22,400? I converted already in my head. That video lesson, go watch it. It explains everything you have to know on this particular aspect, okay? Because here was the CM cube, that's why I have to make sure that here is the CM cube as well. Are you following me? So what becomes the next thing I do? Because now you can see the two. Now in this aspect, we relate 2 formulas. For number of moles, we have 5 formulas, 5. But in this aspect, in solving questions under, you know, stoichiometry, mole concept, relating formulas, with the maximum formulas we can relate is just 2. And you can see that this particular practice question has everything we need, because we can, number of moles is equal to this, number of moles is equal to this. That means both of them are equal to each other. Hope you are following. It is extremely easy. So moving further, since I said mass of number of moles is this and number of moles is this, that means both of them can be related together, and we have something like mass, okay, divided by molar mass, or we can as well call it molecular mass, okay, is equal to volume at STP dividing 22,400 cm cube. Here can be in dm cube if the volume was in dm cube, and if it's going to be in dm cube, it's not going to be called 22,400 but rather 22.4. So then what do you think I'm looking for? What is unknown? We were given mass. Gram is mass, so 0.07 grams was given. We were given volume, right? Yes. Were we given molecular mass or molar mass? No. This is what we are looking for, to impute it into this particular aspect to get our molecular formula. So let's get our molecular mass or molar mass. Hope you are following. It is simple, okay? So it's going to be cross multiply with times this. It's going to be mass times 22,400 cm cube dividing volume, which is already known. So molar mass is going to be equal to, what's the mass, class? The mass is 0.07 times 22,400 dividing, what's the volume? The volume was given to be 56. This is the volume, okay? cm cube. So what becomes the molar mass? Let's solve together and get the molar mass to impute here. So it's going to be 0.07 times 22.4, sorry, not 22.4, 20,400, okay? Answer dividing 56, that is 28. So molecular mass is 28. Wow. So what do we do next? Very easy. This is when we want to use this formula. Listen, it is simple. You know that we've gotten the molar mass to be 28, so molecular mass to be 28. So what do we do next? We have to use this formula because it has mass in it. So we have empirical mass N is equal to molecular mass. What is the molecular mass gotten already? Molecular mass, I'll write it. It's going to be empirical mass. How do we get our empirical mass? First of all, equal to 28, because these are molecular mass. How do we get, and there's N outside here, but we'll work on this. How do we get an empirical mass? You get your empirical mass from your empirical formula. You get your empirical mass from your empirical formula. What was the empirical formula gotten in solving this question? CH2. And what do we do to get empirical mass? It's still like solving molar mass as well, okay? Because it's an empirical formula, that's why we are getting empirical mass from it. And you know, it's here is 12 plus hydrogen 1 times 2. Hope you know what I'm doing. Simple. It's going to be 12 plus 2, that's 14 for methane, okay, 14 grams per mole. So then grams per mole, okay. So what do we do next? here is going to be 14. I hope you're following me. Empirical mass is going to be what? 14 bracket n. So what do? We make n subject of formula. Making n subject of formula, we divide both sides by the coefficient of n, which is 14, and here is 14. Cancel. So definitely, what become n? Okay, because there is n remaining. So when 14 cancel, what become n? N is going to be 28 over 14. So 28 divided by 14. That is 2. Wow. So n is equal to 2. So then we have to go back into this particular aspect, this first part, empirical formula ends from molecular formula. So we are looking for molecular formula, and then our empirical formula is this CH2, remains CH2. What was the n value? 2. So then what do we do next? We times everything inside the bracket. So it's going to be C2H4. Wow, the answer is option C. It's very easy. It's just about practice, okay? It's very easy. Now, if you are finding my video lessons helpful, make sure you subscribe to my channel and also share these lessons with your friends. So we'll go over to the next practice question. Okay guys, moving further, let's get into the next practice question, and it says tincture of iodine means iodine dissolved in. Simple. Whenever we hear the word tincture of iodine, it is a mixture. Tincture of iodine is not an element. It is not a compound. It is a mixture, combination of two different substances together. So tincture of iodine, that means iodine should be there, dissolved in, what's the other? It is actually an alcohol called ethanol. Do you understand? An alcohol called what? Ethanol. Alcohol called ethanol. Do you understand? And this mixture is used for wound dressing in the hospital. Do you understand? So moving further, let's go over to the next practice question, which is the reaction between an organic acid and an alcohol in the presence of an acid catalyst is known as. Very easy. What is this organic acid we are talking about? Listen, the reaction between an organic acid. What is this organic acid we are talking about? Reacting with what? Alcohol. Okay, reacting with alcohol in the presence of an acid catalyst. Okay, let's use the word acid catalyst, but specifically there should be something here, but let me just write it in full. Acid catalyst, what becomes our product? So this organic acid we are talking about is simply called alkanoic acid. Note it. The organic acid we are discussing here is called what? Alkanoic acid. Alkanoic acids can also be regarded to be called carboxylic acids. They're also called carboxylic acids. So on these, reacting with what? Alcohols. Okay, so what happens? Very easy. What do we get? It's simple. The reaction between alkanoic acid and alcohol, it gives rise to something which is called esters. It gives rise to something called what? Esters. Though there is a reason to which this is formed, not the normal ester, ester. So there, not just ester, we get water. Do you understand? So the formation of ester should be called esterification. So the answer to this question becomes option C. So how does this process works? Very easy. Here is the general formula for alkanoic acid. Alkanoic acid general formula is RCOOH, whereby that of alcohol is simply ROH. So for you to locate any compound that is an alcohol, you see ROH, you see OH at the end, you know that, oh, this compound is an alcohol. So what do I do next? Very easy. So what do we get? How do we form the ester, and how do we form water? So what do? I want to write out this compound structurally the way it is written. RCOOH. RCOH structurally is written as this. Listen carefully and watch. Arrow bonding to carbon, and this carbon is bonding to this oxygen with a double bond, and then this same carbon is bonding to OH as a group. So this is the structural form of what? Alkanoic acids. Yeah, also called carboxylic acid. I believe you know how I got it. This is the arrow, this is C, this is the O, and this is OH. They are together, reacting with what? Arrow bond OH. So what do we get? Simple. Actually, what happens is that the arrow part of this, from the arrow down till, this part of the compound, listen carefully, moving towards this other oxygen, and it's, cleaves it from the hydrogen, removes it from the hydrogen, separates it from the hydrogen, and then goes back like this. So if you observed what happened, the connection is how both of them, the reaction mechanism, this arrow bond to carbon, bond to oxygen, and bond to the other arrow, and this oxygen. So it's something like this, everybody, something like this. I believe you are following. It's simple. It's very easy. So if we bring everything together, what are we having? Arrow, C, O. Okay, O should come before arrow. Here should be O and R. Do you understand? RCO, arrow. This is ester. This is general formula for esters. Esters are also called alkanoids. Esters are also called what? Alkanoids. Sorry, alkanoids. Do you understand? Plus water. How do you think this water was formed? Very easy. You know, this OH. This is the H first remaining, and this OH. Do you understand? HOH, H2O, 2H and 1 oxygen. Do you understand? That's how this water was formed. Do you understand? So this is the answer to the question. Esterification is the answer. But this reaction is basically a reversible reaction whereby it proceeds forward and also backward. So the forward is esterification. We forming this is esterification. But if we are going backward, it's something. If it's going backward, it's something. You can see that there's presence of water. So this water will serve as a splitting agent. The water will split back this ester we form to get something. So whenever water is involved in a reaction, we call that hydrolysis. Using water to split a compound, they call it what? Hydrolysis. So if it was the backward reaction they asked us, so the answer is going to be hydrolysis, option D. Are you following me? So that's for that. So moving further to question number 7, which says an example of an alcohol is, you just check for the compound that has OH in it. Remember I said the alcohol, they have OH. So you just look for the one that has OH, which is option D. Do you understand? All of this is not an alcohol. You can see that COH is here, COH is here. So what will you call this? This is an alkanoic acid. Actually, this is an alkanoic acid. These other guys, they have where they belong to. Do you understand? They are actually very easy. But I'm not talking about them. I'm answering that question so you know how it's done. So moving further to the next practice question, which is the most common type of reaction which alkanes undergo is. Now, first of all, we have to know what alkanes are, or which group of compounds are regarded to be called alkanes. First of all, you have to know that alkanes are also called paraffins. Okay, and the first member of the alkane series is called methane, which is CH4. Are you following me? Simple. So what do we do next to understand this aspect, that the type of reaction that is specific to alkanes? Another thing about alkanes is that they are sp3 hybridized, okay, and they are saturated compounds. They are saturated meaning that they are all completely filled. Here is what I mean. This is methane. This is methane. Methane is made up of carbon and hydrogen. Methane is an hydrocarbon. Do you understand? So on this, what do we do next? You can see that it's between carbon and hydrogen. So the central atom that should be here is carbon, bonding to how many hydrogen? 4. H, 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 and H. So I want to explain to you the type of reaction that is seen mostly in alkanes. So let's say, for instance, to have more understanding about chemistry calculations and solving all of this type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAMB exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen. As this methane reacted with, let's say, chlorine, for instance, Cl2, for instance. I'm coming, you just listen. What do you think we'll get? Simple like ABCD. This is alkane, this is chlorine, a gas. You know, it's of 2 now. Cl2 means that we have 2 of it. So then, the type of reaction that they actually undergo is substitution. They always do work more of substitution, trying to remove one and replace with another. So let's say we have these 2, want to replace everything here into this compound. What do you think we'll get? So first of all, let's say this chlorine replaced this hydrogen, remove this hydrogen. What do you think we'll get? So definitely we're going to get something like H again, bonding to carbon, bonding to that Cl we've added and removed. So we've substituted Cl here, so it's going to give us something. Okay, hydrogen still remains and hydrogen here. Let's say this other chlorine that's here, we actually added it. Let's say we remove this one as well. Do you understand? So we've removed this one, removing this as well. So what do you think we have? Cl. Do you get the point? So you can see that we've removed how many hydrogen here? We've removed just 2 hydrogen. So plus 2 hydrogen, which will give us, which we're gonna have as H2. Do you understand? So in general, how are we gonna write this compound? Very easy. You can see now it's between carbon, we have 2 hydrogen and 2 chlorine. So it's gonna be something like this. Carbon should be the central atom, making up made up of hydrogen 2 and chlorine 2. Do you understand? It has its own name, but I'm not going to drive towards that particular aspect. But you can see that I've substituted one for the other. So that's substitution reaction, and seen mostly in what? Alkanes. For the other, which is addition, is seen mostly in alkenes and alkynes. Note that. Though I've not explained that, but just note it. Alkenes and alkynes, they undergo addition reaction. You add using what we call an addendum. Do you understand? So that's for that. So let's go in. So let's move over to the next practice example. Okay guys, let us move over to the next practice questions. Now, if you find my video lessons helpful, make sure you click on the subscribe button to my channel and also share my videos with your friends because it will help you all. So let us progress. The question says, cellulose and starch can be classified as one of the following. Are cellulose and starch sugars? Are they sucrose? Are they hydrocarbons? Or are they carbohydrates? What is the answer to the question? Now, this must be noted. Actually, cellulose and starch are carbohydrates. Carbohydrates are of two groups. We have simple sugars or simple carbohydrates. You know, carbohydrates are actually sugars. But we can't just call cellulose as sugar. Do you understand? Because this is the umbrella word that should, you know, shield all of them. So we have two of them, simple sugars and also complex sugars. On the simple sugars, we have what we call, there are so many, but let me just give the popular examples: glucose, fructose, galactose. Okay, glucose, fructose, galactose, they are the very popular guys. We have the likes of arabinose, we have ribose, we have the likes of ribulose, we have the likes of erythrulose, we have the likes of glycerose, also called glyceraldehyde, we have the likes of dihydroxyacetone, okay, we have the likes of pseudoheptulose. All of these are examples of simple sugars here. But on complex sugars, they include, you know, starch, which we've seen here, cellulose, even glycogen and the rest. Do you understand? Amylopectin, amylose, all of these are examples of complex sugars. So the answer to this question becomes option D. Okay, so that's for that. So let's get into the next practice question. They are asking us for the name of this compound. Now, if you are finding naming organic compounds difficult, I already have a video lesson that explains that particular aspect from the scratch. So go watch that video lesson. The link also will be in the description of this video. So let's get into this question. They are asking us for the name of this compound. First of all, I have to look at the functional group. Here is the functional group of this compound. Yes, this is looking like an alkanoic acid. Remember, alkanoic acid is something like RCOOH. This is COOH. So definitely this should be an alkanoic acid. But which alkanoic acid is this? Is this methanoic acid? Because you know that an organic compound with one carbon should be called meth, you start with meth. If it's two carbons, you start with X. If it is three carbons, you start with prop. If it is 4 carbons, you start with but. Do you understand? I already have that. I've explained all of this in that video from the scratch. So go watch that video. So on this, what do we do next? This compound has how many carbons? 1, 2, 3. Wow. So it should be prop. Which one has prop? I'm saying proper now. No. Is this compound? Have I ever said anything like alkanal before in this video? No, I've not mentioned that. So definitely that should not be. You know, funny enough, option A and option D, they are the same. Acetic acid is same as ethanoic acid. You know, ethanoic acid is an alkanoic acid with 2 carbons. So let's say, for instance, we had just 2 carbons here. This carbon was down here, 1, 2, and you know the stuff, 1, 2, and the functional group. Definitely it should be ethanoic acid. But now it has 3 carbons, so definitely it's propanoic acid. It is propanoic acid. You can see this is propanoic acid. It's very easy. So guys, we've come to the end of this video lesson. If you find my video lessons helpful, make sure you subscribe to my channel and also share with your friends. Thanks for watching.